Hi, my name's Logan,
And I'm Sean.
and our senior project is inventory management for Atlas Copco Mafi-Trench. Our technical advisor is Dr. Tolly Freed, and our administrative advisor is Dan Waldorf. In this presentation, we'll start with our problem statement and then run through steps 2 through 5 for each area of focus mentioned in our problem statement. Then we'll give our recommendations and finish up with the organizational impacts of our project.
Okay, so here's the problem statement we have created for this project. But it's necessary to point out that before creating this problem statement, Logan and I both got a grasp on the current state of inventory management at Atlas Copco by utilizing various engineering tools, analyzing historical data, and by researching upwards of 20 literature reviews. This all prompted us to identify the 3 areas of improvement which are highlighted in this problem statement. These include the tediously long cycle counting process, the excessive amount of inventory held, and the ergonomic hazard presented by extremely heavy inventory bins. The picture shown here is of the small parts area in the material control department, and the steps 1, 2, 3 on the left and 4, 5, 6 on the right depict the original counting and recording of inventory process. After conducting time studies on the counting and recording step, which is the 3rd step shown here in the cycle counting process, we can conclude that this step accounts for about 1 hour of the 2-hour cycle counting process. Cycle counting is inherently a non-value-added process, so it begs the question, why is it done in the first place? Well, if we jump to the last bullet point here, there does exist financial and operational reasons for maintaining a high inventory record accuracy, including for taxation purposes, to avoid the need for a production hindering annual audit, and to make sure that the MRP system, which Atlas Copco uses through SAP software, can function properly. Now, that being said, one alternative to the current cycle counting process is to improve upon the cycle counting process instead of removing it completely, as is such with the other 2 alternatives. Now, another attractive alternative is a Kanban style inventory replenishment. And an important question for this alternative would be, is a visual inventory management system sufficient for tracking these small value items? And this quick calculation to the right shows that even if the MRP software were to get 5% off the actual inventory count, it would still only total up to about $4,000, which is still half of the total operational expenses associated with cycle counting. A third alternative we'd like to discuss is point-of-use inventory management system, and this provides many lean manufacturing benefits, such as a reduce in motion of people and a reduce in transportation of material. This is a quick financial breakdown that we generated of a point-of-use in combination with Kanban inventory management system. Payback period would be just over 5 years. We'd have a yearly cash flow of $2,420, and this accounts for a third-party audit of $10,000 every year. In terms of implementation, we were able to improve upon the current cycle counting process. We recorded the weight per part of about 200 small part inventory bins and created a cycle count Excel sheet for the material control employees to use during their cycle counts. The cycle counting Excel sheet will allow material control employees to update the catalog of part numbers and their respective weight per parts, and also to conduct quick cycle counts. Using the cycle count Excel sheet, the counting and recording of inventory saw an average reduction in time of 87%. This reduction in time needed to count and record inventory items reduces the overall process of cycle counting by nearly an hour. And the possible savings shown in the bottom chart reflect a material control employee coming into work at 5:45 a.m. instead of at 5 a.m. as was the case before the improvement. Our next area of focus within inventory management is ordering. Currently, Atlas Copco uses an ordering cost of $180 per order, a carrying cost of 3% per part per year, and they seem to not be identifying excess inventory as waste. This is best demonstrated by the data we collected on the 7th of May, in which we totaled nearly $90,000 of inventory that has been sitting on the shelves for over 19 months. In a report by the Institute of Management and Administration, George Miller, a certified production and inventory manager, states that it is typical for mid to large size manufacturers, such as Atlas Copco, to have inventory carrying costs of 25 to 30 cents on the dollar annually, for reasons such as estimated loss of return on capital tied up in inventory, average yearly loss stemming from material obsolescence and pilferage, cost of labor to receive, stock, identify, move, and maintain materials, estimated yearly cost of top management time spent on solving inventory-related problems, among others. So for the sake of our calculations, we will be using a carrying cost of 27% rather than 3%. And the calculations we will be demonstrating include the following lot sizing algorithms: lot for lot, which is the simplest approach and generally used by MRP, economic order quantity, period order quantity, part period balancing, as well as value ordering, also known as bulk buying. For our order quantities design, we'll be using an annual carrying cost of 27%, and ordering cost will remain at $180, and we will consider Atlas Copco's fixed lot sizes and safety stocks. This is the Atlas Copco order quantity Excel sheet, which we have created to compare total costs associated with inventory when using different ordering algorithms. To demonstrate how this works, I'll first enter in a new part number here under information. As I do so, the price per part, safety stock, and fixed lot size will all be updated with current Atlas Copco information. Next, the material control supervisor can update the demand schedule based on material requirements planning. And when doing so, the material requirements graph on the right will be updated simultaneously. Once the demand schedule is updated, you can come down to the automatic calculator where 3 different ordering algorithms are calculated automatically. First, we see bulk buying at a total cost of $2,001. Next, we can compare lot for lot and EOQ. Lot for lot we see at $1,300, and EOQ in this scenario is the same at $1,300. Unlike the automatic calculator, which uses a series of logical if statements to calculate order receipt for you, the manual calculator requires input for order receipts. The manual calculator will also give you a description of each ordering algorithm to give you an idea of when an order should be placed and how much quantity should be bought. In the manual calculator, we also included 2 ordering algorithms which were not included above, and these are period order quantity and part period balancing. First, period order quantity is computed by dividing the EOQ by the average demand per month. Don't be fooled by this EOQ though, because it's rounded to the nearest multiple of the fixed lot size. However, when computing the periods per order, the actual EOQ is used. So we see that the periods per order is 4. So we can come over to order receipt and we can order the first 4 months supply. We see that it totals to 19, and we can round this up to the nearest multiple of the fixed lot size to 30. Then we do the same starting in May. We sum the next 4 months, and we see a total of 55. We can round this to 60 to accommodate the fixed lot size. And then we go to September and do the same. We get total costs associated with inventory of $1,416, which is a bit more than the EOQ and lot for lot algorithms we saw above. Lastly, in our manual calculator, we included PPB algorithm. This stands for part period balancing. This is described as the number of periods covered by the replenishment is made so that cumulative carrying costs and ordering costs are as close as possible. This can be seen in the chart to the right over here. Carrying cost is calculated by the number of months that inventory will be held in that month, by the carrying cost per month, by the demand seen in that month. The cumulative carrying costs are then added up, and in this scenario we see the cumulative carrying cost in May is the closest we'll get to 180. Therefore we order inventory through May. We can sum here January through May, and we get an order receipt of 25, and then we round this up to the nearest multiple of our fixed lot size, 30. And then we do the same starting in June. Here we see the closest cumulative carrying cost to our ordering cost of 180 is in September. Therefore we order inventory to cover through September from June. We get an order receipt of 64, and we round this up to the nearest multiple of our fixed lot size to 90. This gets us a total cost of $1,295, which is our best solution yet. After analyzing Atlas Copco's historical order quantity data, we believe that they have the opportunity to save $500 per SKU per year by utilizing order quantity algorithms. A financial breakdown of investing in order quantity algorithms resulted in a payback period of 0.03 years and a return on your investment of over 31,000% after 10 years. Therefore, we believe it's more than worthwhile to begin utilizing order quantity algorithms.
When assessing cycle counting at Atlas Copco, we talked to a lot of employees in the material control department. One of the guys that we talked to was explaining to us how he suffered a pretty serious back injury, which kept him out of work for over a year. Obviously, a work-related injury entails workers' compensation, and that puts the company at risk. So we decided to dive into the ergonomic risks associated with cycle counting. We looked at the Wisha lifting calculator with a bin average of about 100 pounds, although some bins can reach 150 to almost 200 pounds. And what we found was that more than 80% of the lifts are risky. In these images, you can see how Atlas Copco's materials are stored in bins, which are about 2 foot by 2 foot. And the bins are on shelves which go 5 or 6 rows high. So if you're trying to lift a 150-pound bin from the 5th row, which is above your head, that's nearly impossible to do by yourself, let alone do without injuring yourself. We looked at 3 alternatives for ergonomics. First was improved shelving, which would feature bins that could roll off the shelves on tracks. This could be a problem though because the bins are really heavy. Next, we looked at reorganizing the bins themselves into compartmentalized bins or industrial style poker chip bins where you could stack material in different columns. Lastly, we looked at RFID because our literature reviews told us that RFID provides the highest inventory record accuracy, gives a huge reduction in cycle counting time, and we found a high correlation between the level of automation of a process and a low level of ergonomic risk. These images model the reorganized bins. If a part is 2 inches tall, and the bin is marked off in 2-inch increments, then just by looking at how high the stack is in a column, you can get a sense of how many parts are in the bin. To test our ergonomic alternatives, we decided to conduct another Wisha lifting calculator assessment with an exaggerated maximum weight of 50 pounds. The reason for this weight is that on average, a part is probably 10 to 30 pounds, so just for this example, we wanted to exaggerate it at 50 pounds and see what the effects would be. In doing so, we found more than 70% safer relative to the current state, and this is using RFID or the reorganized bins. Our literature reviews informed us that the cost of a back injury as of 2017 is $31,000. Assuming that Atlas Copco suffers 1 injury every 5 years, that equates to $6,000 in savings per year. RFID costs $20,000 up front with an annual cost of $4,000 to $5,000, whereas the bins come at a cost of $6,000 with no annual cost. Both of these payback periods are under 5 years, which is the threshold for injuries, and the rest of the financial figures are quite remarkable, with the return on investment being very high and the internal rate of return greater than the discount rate by quite a bit.
In regards to cycle counting, we recommend that the material control employees continue to use the small parts cycle counting Excel sheet. In addition to this improvement, we recommend further research into the implementation of a point-of-use Kanban inventory management system, with an emphasis on where to place inventory on the manufacturing floor based on usage rates. We believe this is the eventual best route for Atlas Copco due to its lean manufacturing benefits. Next, we recommend that the material control supervisor places a greater emphasis on carrying cost when ordering and familiarizes himself with the different ordering algorithms presented on our order quantity Excel sheet.
For ergonomics, we recommend investing in acro-mills bins with adjustable dividers that allow for materials of different shapes and sizes to be easily compartmentalized. This allows for a visual clean hand cycle count. At this time, RFID seems too costly of an investment for something that can be accomplished with simple bins.
In our cycle counting improvement financial breakdown, we assumed employees would not need to come in as early due to the reduction in time. However, management now has the opportunity to find other value-added work that can be done during this time. The main shift in thinking that needs to occur with order quantity is that excess inventory is a waste. Oftentimes, inventory isn't noticed until a stockout occurs, and this allows excess inventory to build up without being noticed.
The material control department might wonder if they have enough space to organize their inventory into compartmentalized bins. But with the future shift to a point-of-use inventory system, that'll remove a lot of bins from inventory and free up space for these new acro-mills bins.
And that's a wrap for our senior project. Logan and I had a great time and a great learning experience. So thank you to everyone that helped us along the way, especially those mentioned on this slide. We look forward to hearing your feedback and answering any questions you may have.